Good afternoon, everyone, and welcome to this webinar on new legislation on electromagnetic fields, control of EMF at work regulations. We're very pleased to welcome Julia Clark of the IOSH Communications Media Group, who is delivering this session today. Before I hand her over, I'd just like to mention a few things. Firstly, for those of you who haven't attended one of our IOSH webinars, I am Ben Pollard and I take care of the technical aspects of these sessions. Any problems, and I should try to assist as best as I can. On your screen then, most likely located at the top left-hand side, you'll notice a small bar with some written options on them. These are chat and Q&A. If you have any technical issues and need to message me at any point, please use the chat option. And if you have any specific questions for Julia at all about the session, please use the Q&A option and you can ask your questions here. You can also open and minimize these boxes at your own leisure. Should a message come through, it will flash orange. So with all that said, I shall now hand you over to Julia. I hope you all enjoy the session.
Good afternoon, everyone. Thank you for joining us today. My name's Julia Clark and I work for a company called Link Microtech. Link are by far the most experienced UK electromagnetic field safety equipment supplier, and we do training, consultancy and equipment sales. My personal background and interest in this subject comes from being a broadcast engineer for many years, and from that I became a safety professional specialising in radio frequency safety. Link are the UK agent for NADA. That's the world's largest supplier of EMF safety equipment, with 95% of the patents in this field. Today, it has to be for quite a short introduction. There's quite a lot to say on this topic, obviously. And at Link, we run courses from half-day awareness courses to full-day courses on measurements. So this is very much to whet your appetite, and I hope it gives you a flavour of what's required by the new regulations. So first of all, nothing new. All employers have a duty to assess risks arising from the work undertaken and to put in place protective or preventive measures to reduce the risks they identify. We all know that. We're doing risk assessments all day, every day, aren't we? And we're required to do that by all previous safety legislation. So the EMF directive and then the resulting control of EMF at work regulations are just intended to help employers comply with those duties, but for the specific case of electromagnetic fields in the workplace. And there's a definition of what electromagnetic fields are that come from the directive, and they define it as electromagnetic fields are defined as static electric, static magnetic and time varying electric, magnetic and electromagnetic fields with frequencies up to 300 gigahertz. So just for those of you who haven't got a mental picture of what an electromagnetic wave looks like, here's one we use in nearly every course that we deliver. This shows that the electromagnetic wave has two components. You've got the electric field, which is shown here as vertically polarized. So the reddy orange wave, if you like, with the E and the arrow is the electric field, and the H field, which is the magnetic field, is shown in blue, and they're at right angles to each other. The other important quantity to understand is the wavelength. So that's shown as the Greek letter lambda in this drawing, and that's from one peak to the next, and that's the length of one cycle. And then the other characteristic that a wave has is frequency. So that's how many of those cycles you get in a second. So one cycle per second is 1 hertz, 1,000 cycles per second is 1 kilohertz, 1,000,000 cycles per second is a megahertz, and 1,000 million cycles per second is a gigahertz. And you've probably heard people talk about kilohertz and megahertz and gigahertz, and that's what it means. So this diagram just shows the electromagnetic spectrum, and this is just really to put it into context and really to highlight the difference between ionizing and non-ionizing radiation. the word radiation is sometimes be a bit scary to non-technical people, and radiation just means the emission and transmission of energy through space. If you look at this spectrum, the shorter wavelengths and the higher frequencies, so above ultraviolet on the right-hand side of the slide, show X-rays, gamma rays, cosmic rays. That's all ionizing radiation, and that's not what we're talking about today. So what we're talking about is the lower energy electromagnetic spectrum, which goes up to just below light, and that's all non-ionizing. So within that slide, then you can see the various bands in the radio part of the spectrum, microwave, UHF, VHF, and all of that. And then down at the low frequency end, electricity supply, ELF, and all of that. So having defined electromagnetic fields as static electric, static magnetic, and time-varying electromagnetic fields with frequencies up to 300 gigahertz, the effects and the technologies that use these are very different. So at the low frequency end, then you've got things like resistance welding, induction heating, electric trains and trams, and anything where you've got electric circuitry that's carrying more than 100 amps in 100 amps of electricity. At the radio frequency part of the spectrum, so going up in frequency, things like medical equipment, dielectric welding, semiconductor processing, telecommunications, broadcast. And then higher frequencies again, up in the microwave region, things like radar, microwave heating and drying, satellite uplinks, and things like that. The most important quantity, though, when we are doing a basic EMF risk assessment is how much power is there available from the source? And after that, how close do you have to get there to get to it, and how long do you have to be there? So when we're looking at powers, we've got a simple traffic light model here. So down in the green part of the model there, you've got things that are very low power, smart meters, GSM mobile phones, Wi-Fi, DECT, all that kind of stuff. The power is so tiny, there really isn't enough energy there to heat you up or cause any damage. So instantly, when we do our risk assessment, we can judge those to be low risk. Then you've got things in the amber part there. Yes, potentially you could get some harm from them, but actually it would be quite difficult, and you'd have to really go out of your way to get an overexposure from things like mobile radios or CB radios. The things we're most interested in as electromagnetic field safety geeks is the stuff that's in the red box. So anything where we're talking about the power in terms of kilowatts rather than watts. So things like DAB radio transmitters, microwave ovens, induction heating, industrial dielectric heaters and things like that. There's significant power there, and they do need to be managed properly. Another important thing that we need to consider is that there's a difference between intentional and unintentional emitters. So when I talk about intentional emitters, I'm talking about technologies where the electromagnetic field is the product that you require and use. So for example, broadcasting, telecoms, aircraft radar, RFID, Wi-Fi, all those sorts of technologies. We deliberately want those EMF sources because we're using them for a purpose. And organisations that create and use those sort of sources have typically managed them very well in the past. They know that they're creating RF at high power, and that they have managed it well, and there's good technology available to assist in that. So, for example, workers who work on broadcast and telecoms antennas will use NAD alert personal monitors. So that's a personal RF monitor, and that will just bleep when it gets to 50% of the action level, and it alerts the worker that there's an issue. very tried and tested technology and very well used, and has been a particular success story. Moving on though to unintentional emitters, that's where the electromagnetic field is actually a byproduct and it's not wanted or needed. Often that magnetic field is produced by high electrical current flow. So if we think about welding, electricity supply and distribution, chemical process, things like that. And these are probably the areas where electromagnetic field safety might have been overlooked in the past and maybe has not been assessed or considered. And sometimes it's in these kind of industrial environments where people are really kind of playing catch up with these new regulations. So these are safety regulations, and I guess what you're all thinking is, well, what effect do they have? What effect do they have on people? And that's the most important thing, isn't it? So when we look at the static fields, if you have a very high static magnetic field, that can cause vertigo, nausea when you move through the field. So an example of that would be people working close to MRI scanners, where the workers who work around those know that they need to walk slowly and carefully, otherwise it can make them feel sick. In the low frequency alternating fields, you can get sensory, nerve and muscle stimulation, and that can cause sort of strange effects, make your hair stand on end, for example. As you go up in frequency, you get a mixture of the heating effect and those sensory effects. So there's a sort of an intermediate area where you get the both. Once you get into the radio frequency part of the spectrum and the area that we call the body resonance region, the electromagnetic fields cause the body to resonate, you become a good receive antenna, and you can absorb a lot of that energy. And so the safety effect there is a heating effect. So we're actually trying to prevent that heating becoming significant. And as we go higher in frequency again, up into the sort of microwave region, it stops being a whole body heating effect and starts to be more about the heating of surface tissues. The thing that's important to note about these is that it's a non-stochastic effect. So effects occur at relatively high field intensities and they won't be apparent below certain thresholds. So below the lowest action levels, that there shouldn't be any effects on people who aren't at particular risk. We also, though, need to consider indirect effects. Those indirect effects occur when you've got the presence of an object within an electromagnetic field, and that may become the cause of a safety or health hazard. So, for example, interference with medical electronic equipment, interference with active implanted medical devices such as pacemakers, defibrillators, cochlear implants, things like that. Interference with passive implants, so artificial joints or metallic plates or pins that people might have had to repair them after a road accident. Any effects on shrapnel or body piercings, projectile risks, particularly around MRI equipment, and then electric shocks and burns from contact currents when a person touches a conductive object in an electromagnetic field. So if one's grounded and the other isn't, you can get current flow between the two things. And then electroexplosive devices and flammable atmospheres. You can imagine if you've got a spark at the wrong time, the wrong place, wrong time, and you've got a flammable atmosphere, obviously that creates a safety risk. So the regulations that we have derive from the EMF directive that was published in 2013. And the HSC has very much done a copy-out type approach. So they haven't added any additional burden. They've just sort of done the bare minimum of what's required by the directive. So this flow diagram just is explaining how it works. So Article 4 says you must assess the risk, you must do an assessment of risk and determine the exposure. Well, in order to decide whether you're at risk or not, you need Article 3, which defines the exposure limit values and the action levels. Just a quick word here about what the difference is between those. So exposure limit value is the actual limit, but those are in terms of values that can't be measured easily in most practical situations. So the regulations include a series of numbers called action levels, which are things that we can easily measure. So they're in terms of things like electric field strength, magnetic field strength, power flux density, things that we have test equipment that we can measure. And if you are compliant with those action levels, then you're deemed to be compliant with the exposure limit values. So having assessed your risks and you've made some measurements, or you've got an assessment of what the levels are, you've compared those with your action levels, and then you come to the decision box in the middle there, are electromagnetic fields of risk to health and safety? If no, then you need to do no further action under this EMF directive, but you've got general duties under the framework directive. And I would suggest at that point you write that up, you decide when to review it, and it's job done. If they are a risk to health and safety, then you need to look at provisions aimed at reducing or avoiding risks. And often in the sphere of electromagnetic fields, distance is your friend. So sometimes it's just about moving the operator to a different position where the fields are lower. We're talking about assessment of exposure to people. So you need to move your people to somewhere safer. Article 6 says that we need to provide worker information and training, and there is some prescription around what should be in that training. The training needs to include, for example, definitions of what exposure limit values are and the action levels, and also needs to include information around the work that the workers themselves are doing, so their local risk assessments for their workplace. Moving on then to Article 7, consultation and participation of the workers. Well, again, we've already got a legal requirement to do that in the UK. And Article 8 says that under some circumstances you have to do health surveillance according to national law and practice. So I promised that I would give you some information about where to start and where to get some good help on this. And I'm going to point you now to the EU Practical Guide, which was written for the EU by the team at UK's Public Health England. And they're really useful documents for those who need to do detailed assessments, and also for those people who can just use the lists that are in the first volume to demonstrate that all their sources are trivial. So if you look at volume 1, in the first couple of chapters, there's lists of particular work equipment, and it'll tell you whether you need to assess it or not for everybody and for workers at particular risks. I think that's a really good place for people to start. There's also, I would say, don't print it out unless you've got a tree or two to throw away, because there's a lot of information in these guides, but a lot of it is technical annexes and you don't necessarily need to read it all. If you're terrified of starting because it looks too big, download the guide for SMEs, and the guide for SMEs just gives you a very simple place to start. And the second volume of the practical guide has a lot of good case studies. And again, it might be that you're trying to assess a situation where there is a case study that's relevant, and it'd be worth looking through those and see if any of them relate to the situation that you're trying to assess. So one thing that's very important, that really is a bit of a game changer compared to what we've done in the past, is that both the directive and the Control of EMF at Work regulations define that you have to do specific assessments for workers at particular risk. And it gives you an example of 4 different groups, but it's a for example, so there may be other people in your workforce who may be deemed at particular risk. But the ones it lists are workers wearing active implanted medical devices. So that would be things like pacemakers, cochlear implants, things like that. Workers with passive implanted medical devices. So as I mentioned before, stents or screws or plates or whatever. Workers with medical devices worn on the body, so an external hormone infusion pump, so somebody with an insulin pump or somewhere else, and pregnant workers. So workers in any of these groups might be at greater risk from EMF than the general working population, and so they should be subject to specific risk assessments. In considering whether workers might be at particular risk, then you need to give consideration to the frequency, level and duration of exposure. So in that context, frequency is the how many hertz or gigahertz or megahertz is the signal on, not how often. So in the practical guide, there's some practical exposure scenarios that are very highly specific, and so whilst your particular situation might be in the guide, it might well be on the scope of the guide. And bear in mind, please, that these EU practical guides relate to what's in the directive and doesn't necessarily ensure compliance with whatever each individual member state has done with their regulations. As I said earlier, the UK HSE did follow the directive fairly closely, but there are a couple of small exceptions, so just make sure that what you're doing is compliant with the UK regulations. So do check for that. So moving on to the UK regulations then. One of the things that the HSE were very keen on when we were talking about what should go into the UK regulations is they're very keen to make sure that people could do as much of this assessment themselves. They didn't want to have people have to get in outside help. And the first thing they said is that employers must, are able to refer to any credible information to help with their exposure assessments. So an example would be emissions information from the manufacturers. So if you've got a piece of kit, ask the manufacturer what EMF emissions does it have to the worker that's operating the kit. That's all well and good for newish kit, but if you've got very old kit or kit that's been modified or hasn't been well maintained, then you might not get such great information, or the information you get might not be relevant. Then look at industry standards and guidance. For example, the welding industry has produced some really good guidance. The EU practical guides, and of course the guidance produced by the HSE. I should say that I've referenced this guidance, and I have created on our EMF blog page on our website, I have put all these links up, and I think after the webinar I'll ask Ben to send you a link to that, so you can easily download all this guidance. It is all free and it's available for anyone. So for workers at particular risk, it's implied that the employer can only really manage risks if the employer knows about them. So an employer is not expected to be psychic. So as an employer, you can only know about information that your employees have told you. On the other hand, you need to give your employees enough information to let them know that they need to let you know if they are in one of those categories. So you're not completely off the hook. You do need to let your employees, somehow you need to make sure through your training or information that the employees know that they should declare if they're in one of these categories. The HSE are minded to allow some exemptions, and they're called derogations in the directive. as long as the risk is being managed. So two examples are in the MRI used for medical uses and in the military. There's also a general exemption, but that needs to be applied for. So a good example would be for the military one, for example, that they don't have to comply with the exposure limit values in the directive, but they need to have a framework that offers a similar level of protection, and they need to demonstrate that they are managing this risk. So, for example, in the military, there are NATO standards which afford a very similar level of protection, and so that's acceptable. So just a bit about possible outcomes and severities, and I think it's important with all risk assessments that we are focusing on the things that are most dangerous compared to the things that are least dangerous. So the more minor ones would be these for low frequencies, feeling of vertigo and nausea, phosphenes, the nerve stimulation, very small increases in tissue temperature, microwave hearing. All of those are minor and reversible. So the minute you stop being exposed, they stop happening. More serious would be movement of ferromagnetic projectiles in static magnetic fields. Obviously, you don't want metal chairs flying across and embedding themselves in MRI scanners. Interference with implanted medical devices, obviously for the person concerned, that would be very distressing and harmful to their health. And large increases in tissue temperature where the effect would not be reversible. Again, the safety guidelines keep you well below those large increases of tissue temperature, but that's the ultimate outcome if you are seriously overexposed. And then fatal potentially are things like ignition of flammable atmospheres or inadvertent initiation of detonators. People who have those kind of risks so in their industries tend to already be managing that really well. So moving on to the assessment process then, this the points on this slide are taken from the EU non-binding guide for SMEs. That's the nice little summary one that I pointed you to before. So it says, if risks from the electromagnetic fields in the workplace are low, then no further action is required. You just record it, and you record that you've done your assessment, and that's your conclusion. And you think about when you might review it. If the risks are not low, or if the risk is unknown, then you need to follow a process to assess the risk and implement appropriate precautions if you need them. It's possible that the conclusion is that there's no significant risk. In this case, again, you just record it and go on. To assist with the risk assessment generally, and specifically to assess compliance with action levels or exposure limit values, then you might need information on the levels of electromagnetic fields. And first of all, you would go to databases or manufacturers to try and get that information. If you can't get it, or if it's not relevant to your situation, then you might need to look at calculations or measurements. Often measurements can be simpler than you would think. So don't be afraid of that if that happens to be where you have to go. Preventive or protective measures might need to be taken where it's necessary to reduce the risk. It's particularly important, I think, when you're thinking about measurements that do bear in mind that measurements actually can be relatively straightforward these days. There's a survey meter called an ELT 400, which does a weighted peak measurement, and it gives you the answer in percentage of the action level. So it really is fairly simple and straightforward to use, and certainly anyone who's used a sound meter would have absolutely no problems in using a meter like that. So I think people are always interested in seeing a graph of, well, what are these limits? And what this chart is showing for the lower frequencies is the magnetic field action levels from 1 Hertz up to 10 megahertz. And you can see that there are actually 3 different action levels here. So the green one is the action level for limbs. The red one is the action level for the high action level. And the blue one is the low action level. And then the purple one, which is listed Council Recommendation of 1999, is actually the general public assessment. So that's what you would use in your first instance for workers at particular risk. It seems to point us quite closely to that. Well, that's a good place to start. These are the action levels for the electric field from 100 kilohertz up to 300 gigahertz. And that area in the middle where the curve dips down is the human resonant region. So that's the area, the series of frequencies in the VHF part of the radio frequency band where the human body is a really good receive antenna, and therefore we control the exposure more closely in that area. So just talking about specific assessments then. So there's some types of equipment which really don't cause a problem for everyone else, but actually do need a specific assessment for workers with active implanted medical devices. And again, this information has come out of the tables in the EU Practical Guide Volume 1. So things like decked cordless phones, mobile phones, walkie-talkies, electric garden appliances, things that are actually quite low-level emitters, but if used wrongly, could cause a problem for somebody, for example, with a pacemaker. So, for example, people with pacemakers are advised not to carry their mobile phones around in their chest pocket. So that would be very close to the device and potentially could cause interference. People who have pacemakers fitted tend to understand this quite well. So, you know, when you talk to them about that kind of thing, they won't think you're being odd or strange. If a situation is identified that's not covered by the practical guide, then the first step would really be to gather as much information as possible from equipment manufacturers, equipment manuals, or by contacting the manufacturers and trade associations. Important to note that manufacturers are actually obliged to consider electromagnetic fields as part of their CE marking process. So do look at the CE information as well. As I said before, if it's not possible or easy enough to obtain sufficient information, then it might be necessary to perform an assessment by measurement or calculation. So, exposure assessments. You don't always need to perform measurements, but if you do, don't be scared about it, and the process is surprisingly easy. So, the picture on the top right-hand side of your screen is an ELT 400 survey meter, and it's a dream to use, and it gives you readouts in terms of the action levels. That's for the lower frequency application. So that would be used for sort of welding and that kind of thing. And you can set it to low action level, high action level, or limb action level. And it takes frequency into account, and it does a weighted average. It looks at all the harmonics, so it really does take a lot of the hard work away from doing the assessment. The personal monitors are also often used to reduce the risk of exposure for higher frequencies. So higher frequencies, as I said, radio frequencies, when people are working close to radio transmitters and things, then they can just use a personal monitor, and that you know, it keeps them safe. That combined with some training and some information, obviously. So, people always like it when you get to the summary slide. So some action is necessary, but usually risk assessments will be fairly simple, and most, if not all, of the requirements will already be in place. Make sure you obtain as much information as possible. Measurements or calculations aren't always required, but can be fairly straightforward if they are. Really remember to consider workers at particular risk. I think this is an area in our experience where most of the people that we've talked to haven't really got a process in place to, if you say to them, have you got any people at particular risk, they maybe haven't got a process in place for screening people when they start work, and for that ongoing screening when, you know, people can start work and they're not at particular risk and then they can become at particular risk. So you need to have a process for making sure you're managing that. Remember to consider the indirect effects because they can be catastrophic. Preventive and protective measures are often common sense, so don't overlook the obvious. In many cases, the protective measures and controls that you have in place for other reasons may well be providing the distance, for example, that you require to keep people safe from the electromagnetic field. So I'm thinking, for example, of where you have something that has a high electricity supply. You've got a lot of current flowing. Well, you've probably already got something in place to stop people electrocuting themselves. That may well be enough to keep them away from the electromagnetic fields as well, which do dissipate very quickly with distance. We were doing some measurement exercises yesterday on a training course, and people were really surprised by how even 10 or 20 centimetres distance can reduce a field from being, you know, way over the action level to below the action level. So make sure any risk assessments and procedures are well documented, communicated and applied by the workers. So make sure that the workers really understand, if you've put in place new controls, make sure they understand what those are for. And make sure that your assessments are reviewed and updated as required. You know, maybe when you do an assessment, you should decide when you're going to review again. Obviously, you will review again if you change the equipment or change the process, change the amount of current flow or whatever. But if nothing else changes, you might just decide 2 years or 3 years or whatever seems sensible to you. It's not prescriptive. So last but not least, EMF safety issues are usually easy to resolve, and rather than relying on external advice, it's really good to take some ownership in-house. And we're more than happy to help people with that process, so we'll hold your hand a little bit. As I said before, the guide for SMEs is a really good place to start, just because it's only about 20 pages, and so it's an easy read. Do remember, though, that, you know, if necessary, most measurements are pretty easy to perform. Remember that basic risk assessment. So is the equipment high in power? How close do the people have to get to the source, and how long do they need to be there? And absolutely don't forget to remember your workers at particular risk. You know, as an organisation, Link offer consultancy, but our aim really is to help people to set up that in-house ownership. You know, ideally, we'd like our customers to be taking the lead in EMF safety for themselves, and then we can just support them as a supplier. So that was everything that I've prepared today. I can see, looking at Ben next to me, that we have a number of questions. So I'll hand over to you for a question.
Okay, great. So the first question that we've got here is that the practical guide has a cost. Is there any, are there any other means by which to gain access to these?
Well, the practical guide is free. So you can download them off the internet, and certainly we're going to send a follow-up email tomorrow with some of these links on. So no, they are downloadable for free from the internet.
Okay, great. Because measurement is difficult during an assessment, Articles 3 and 4, is there a practical risk assessment tool that supports a common practical approach?
Well, I think the first stage in the risk assessment is to look at the tables in volume 1 of the practical guide. And when you walk around and look at your EMF sources, you probably find that a lot of those will drop out as being no further assessment needed. So I guess it's an iterative process. So I, as a model answer, if you like, I did one at our factory unit in Basingstoke, and I walked around and identified lots of EMF sources. Then I looked it up in the practical guide and said, right, that doesn't need any more assessment. That doesn't need any more assessment. And you gradually work your way to the bits that do need assessment. So you find that maybe out of 30 things you've identified, there's maybe only 2 or 3 that need assessment. Then it's a case of going to the suppliers or looking at the handbooks and trying to find out more information. And it's a sort of a step-by-step approach. So I would say, having then done that, only when you've exhausted, well, what information will the supplier give me? Then you could move to measuring yourself. But one of the things I do think is important is that the HSC are very clear that the suppliers ought to be providing this information, but they won't be providing it unless people are asking for it. So I think as customers, we need to be asking for that information, and eventually they'll get that. You know, that they should get the point that they should be providing this. Next question.
Okay, so this kind of relates back to that question there. For specific assessment, it is challenging to determine with any confidence the frequency level and duration of exposure. So, Julia, can you comment on that?
Well, it depends on the type of equipment that you're talking about. If you know kind of whether it's low frequency, I mean, you should know from the equipment if it's low frequency or high frequency. And so if it was an industrial application, so I keep mentioning welding, but there's lots of other, similar type things where, if you know it's a low frequency application, then you can use equipment that has that uses the weighted peak method. And so it's not necessary to absolutely know the waveform and to know all the different harmonics, because the ELT 400 uses the weighted peak method. It detects all of the frequency components. It compares them with the action level. It sums them all, and it gives you an answer in terms of percentage of action level. So it does the hard work for you. So I don't know if that answered that. I hope it did. Next question.
Okay, great. Are you able to provide an example risk assessment from one you have done previously?
I have done one frequency. I'll have to check whether I can share the one I've done with the customer who I did it for, obviously. But it's not any different from your normal risk assessments. I think we need to get away from the thinking that somehow this is a different beast from every other risk assessment you've done every day of your lives. So for me, maybe on the first iteration round the loop, because this is a new thing, maybe you would do a separate EMF risk assessment. But otherwise, I think in future, you just need to be including EMF as one of the risks that you're looking at in your risk assessment for particular tasks and particular, use of particular machines or whatever. And it's just another line on the risk assessment, and it's exactly the same. It's like, what's the risk? Does it meet the action levels? If it doesn't meet the action levels, what controls do I need to apply the controls and reduce the risk down to an acceptable level?
So in relation to the weighted peak method, what was the name of the meter that you mentioned?
With the weighted peak method, that's the NADA ELT 400.
There's also another question here. Can you give us a ballpark cost of the ELT 400?
Ballpark, about £3,800, but that would be subject to formal quotes, because with the changing of the euro and everything, these things do vary. But yeah.
Someone's actually asked on a separate chat if it's possible to show slide 19 again.
Slide 9. Oh, can you tell me which one that was? What's the title? 19. I'm going to have to count.
But we'll ask a different question and hopefully.
We'll ask a different question and I'll look for it. Yeah.
Okay, so the next one is monitors can alarm when we put them near metal, but how do we know when we are receiving a false alarm and when not? We need assurances that if holding a piece of this metal, our workers are not receiving increased exposure. Can Link provide these assurances?
Okay, so personal monitors and actually most survey equipment have what's called a minimum measurement distance. So when you place a personal monitor, for example, too close to metalwork, so that would be within about 10 centimeters, what happens is you get capacitive coupling from that piece of metal straight into the device. And what that's doing is that piece of metal, if you like, it's like adding a receive antenna to the device. So it's pulling in all the energy it can see and putting it straight into the device. So that is a false alarm. That information actually is available. Most of the equipment will have a quoted minimum measurement distance. So yes, it's not a real alarm, and you're not getting excessive exposure if that distance is less than about 10 centimeters.
Is doubling the distance from source halving the energy, similar to noise or similar rule of thumb?
Yes, it's a similar rule of thumb. It's halving the exposure, if you like. It's an inverse square law. So if you go twice as far away, you're reducing the exposure by a quarter. And if you go 10 times as far away, you're reducing it by 100. So yes, that distance is your friend. So a small amount of distance can make a massive difference in terms of compliance. Gosh, we've got a lot of good questions here. Sorry, the guys here are just looking at these questions and coming up with the next one.
Okay, so other than by distance, can you shield equipment from interference from another emitter?
Yes, you can. You can use mesh. You can use metal if it's grounded. There is lots of suitable techniques. Yes.
Okay, there's one here. I work at the university. Will we need to consider large electrical lab equipment as items that need to be assessed?
Yeah, the guidance refers to anything that has more than 100 amps of current. So if it's less than 100 amps of current, then you don't need to assess it. But it doesn't necessarily mean that if it's more than 100 amps, it's definitely going to be a problem, but you would just need to do some assessment. The first step I would use for that is to ask the supplier about the emissions from the equipment.
Okay, could you advise if using a typical arc welding machine would lead to an exposure?
Well, there was a certain amount of exposure with everything that's using a lot of electricity, but it says in the guidance that MIG and TIG welders are compliant as long as the cable isn't draped over the shoulder. So as long as they're used according to good practice. But certainly the welding industry's done a lot of work already, and certainly I would refer you to the Welding Institute as the experts in that area.
Okay, so are young persons, as defined by MHSAW regs, a higher risk group?
Well, young persons are a higher risk group, mostly by nature of the fact that they don't have a great deal of life experience and common sense, and they're physically there shouldn't be any different. But of course, you know, where you have controls and things in place, you need to make sure that young people understand that. But they are not by nature of being young, they are not any more susceptible to the electromagnetic fields, you know, as below the action levels.
Okay, we've got another one here. We are importing wireless routers and installing these into third-party properties, typically work office environments. Should we be receiving an EMF EC declaration of conformity for the product from the manufacturer? We currently receive an EC declaration quoting a number of EN standards.
Yeah, I think it depends what EN standards those are, and I can't quote them off the top of my head, but certainly the manufacturer, you should specifically be asking the manufacturer, giving you some information that you can quote that says it's compliant with the EMF directive. Most, I would say most wireless routers and the like would be designed to be compliant with the general public safety guidelines. So almost certainly there's not a problem, but I think you should ask for that bit of paperwork that confirms that.
Okay, and so what is the best EMF personal monitor?
Well, from my experience, I think the thing that's most important for an EMF personal monitor is that it has a shaped response, that it doesn't false alarm too readily, that it covers the frequency range of what it is exposed to. So you're looking for a monitor that has a really broad frequency range and has a shaped response. So I would say the Nadala S3 is a perfect device for that sort of thing.
I've also just had a confirmation with regards to the slide. It was the one on EMF directive, if you were able to find that one. Okay, there we go.
That one? Yeah.
Okay, brilliant. So a question with relation to monitors, how monitors can alarm when we put them near metal. Just a follow-up really. With respect to that, is personal contact with the steelwork harmful? Is it acting as a transmitter?
Not if the levels aren't excessive. So if you were if you're at a medium wave or long wave radio site where you've got say you've got a metal fence at a medium wave or long wave broadcast site, and if that metal fence isn't properly isn't properly earthed, then you could have the situation where that has a large degree of RF pickup and therefore could create contact currents. But that's quite an unusual situation, and people that tend to work on those type of sites would understand that. So if you were going onto that kind of site with that kind of issue, that you would be well briefed on that, and certainly you would be aware to avoid that. And certainly all that stuff, is typically earthed.
Okay, there's another one here. So, which is the most suitable propagation model for the assessment of the electromagnetic field for the radio frequencies?
I don't really know if I understand the question. Most suitable propagation model, but I think it depends on the antenna. I'll get back to you on that one.
Okay, there's another one here. Do we need to assess large laboratory equipment?
It depends if it's that's a bit too vague a question, really. If you look at the tables in the EU Practical Guide, it lists various different types of equipment. If that large laboratory equipment isn't included and it takes more than 100 amps of current, then you would have to assess it. But as I say, your first port of call would be to speak to the supplier.
Okay, as well as contacting manufacturers, you mentioned looking up databases for information. What are the best databases?
Well, I suppose the one I'm most aware of is the information that the Welding Institute have put together, and they've done a significant amount of work on this. But but most industry trade bodies will have been looking at this as a trade body. So I would go to the trade body that's relevant for that piece of equipment.
Okay, someone said here, for normal, and that's in quotation marks, for a normal person, what kind of medical exams must be carried out?
Okay, so none, basically. In the Control of EMF at Work regulations, it details that health surveillance should be carried out if somebody has had an overexposure, so if they've exceeded the exposure limit value and are reporting a health effect. So in that situation, so if they've been overexposed and they're reporting a health effect, then they should have some health surveillance. And I guess the thing is that medical exam will depend on what health effect they're reporting. So one of the issues with EMF, say compared to noise, as an example, is that with noise you can do health surveillance. So you can do a hearing test for somebody when they start employment, and then every year you could do a hearing test and you can see whether their hearing is deteriorating. With EMF, because there are no known health effects below the safety guidelines, so below the action levels, there are no health effects. We're looking at, a heating effect, but it's minor and the body deals with it and things like that. So there isn't really anything to look for. So in terms of what, if somebody's reporting a health effect, you would look specifically at that health effect.
Okay, there's a last one here that we've got. Should our electrostatic powder coating equipment have a minimum distance marked on it?
Yes, well, it might not be marked on the equipment, but certainly, again, I would refer you back to the equipment supplier and ask them if it's creating significant electromagnetic fields, then what are those fields at what distance, and what safe distance do they recommend?
There's one that's just come in. Does the rail industry measure EMF?
I am aware that they are looking at it, certainly. As an organisation, we've been talking to some of the people associated with the rail industry, and certainly I know that they are already looking at it. Any more questions?
Okay, so that looks as though I think we've just got one more. So someone has said that there was no health effect reported. So in my company, this goes back to the one about telecoms.
Okay.
So there was no health effect reported. So in my company, do we still have health surveillance?
According to the regulations, there is no requirement to do health surveillance unless it's met that two-pronged thing that there has been an overexposure and a health effect has been reported. So no, you wouldn't have that requirement.
Right, okay. So at that point, we're actually running out of time now. So what we are going to do is there are a couple more questions that haven't been answered, but we will. What we'll do is we'll look at those after the session, and we'll make some written responses to them, which will be emailed out to you all, so that you have the answers to everything. I'd like to obviously thank Julia for attending today and for delivering this session. I hope you all found it very useful. I mentioned earlier in the chat box that our sessions are recorded and the presentations are provided on the they'll be put on the Communications Media Group microsite either later this afternoon or tomorrow at some point. So all that's left to say is, again, thank you very much to Julia. I hope you all found the session enjoyable. I'll be closing the session in the next, probably the next minute, just to allow any final questions or comments that you want to put through before we end the session. But this session will end in about a minute's time. Okay, thank you very much and goodbye.